Hello everyone, today I will be discussing about the topic stacks. What is a stack? A stack is a linear data structure that follows the LIFO last in first out principle. Stack has one end whereas the queue has two ends, front and rear. It contains only one pointer a top pointer pointing to the topmost element of the stack. Whenever an element is added in the stack, it is added on the top of the stack and the element can be deleted only from the stack. In the other words, a stack can be defined as a container in which insertion and deletion can be done from one end known as the top of the stack. Some key points related to the stack. It is called a stack because it behaves like a real world stack, like piles of books, etc. A stack is an abstract data type with a predefined capacity, which means that it can store the elements of a limited size. It is a data structure that follows some order to insert and delete the element, and that order can be LIFO or FILO. Working of a stack. Stack works on the LIFO pattern. As we can observe in the below figure, there are 5 memory blocks in the stack. Therefore, the size of the stack is 5. Suppose we want to store the elements in a stack and let's assume that stack is empty. We have taken the stack of size 5 as shown below in which we are pushing the elements one by one until the stack becomes full. Since our stack is full, as the size of the stack is 5, in the above cases, we can observe that it goes from the top to the bottom when we are entering the new element in the stack. The stack gets filled up from the bottom to the top. When we perform the delete operation on the stack, there is only one way for entry and exit as the other end is closed. It follows the LIFO pattern, which means the value entered first will be removed last. In the above case, the value 5 is entered first, so it will be removed only after the deletion of all the other elements. Types of stacks. Fixed size stack. As the name suggests, a fixed size stack has a fixed size and cannot grow or shrink dynamically. If the stack is full and an attempt is made to add an element to it, an overflow error occurs. If the stack is empty and an attempt is made to remove an element from it, an underflow error occurs. Dynamic size stack. A dynamic size stack can grow or shrink dynamically. When the stack is full, it automatically increases its size to accommodate the new element, and when the size is empty, it decreases its size. This type of stack is implemented using a linked list as it allows for easy resizing of the stack. In addition to these two main types, there are several other variations of stack including infix to postfix stack. This type of stack is used to convert infix expression to postfix expression. Expression evaluation stack. This type of stack is used to evaluate postfix expression. Recursion stack. This type of stack is used to keep track of function calls in a computer program and to return control to the correct function when the function returns. Standard stack operations. The following are some common operations implemented on the stack. Push. When we insert an element in a stack, then the operation is known as push. If the stack is full, then the overflow condition occurs. Pop. When we delete an element from the stack, the operation is known as pop. If the stack is empty, means that no element exists in the stack, and this state is known as the underflow stack. Is empty. It determines whether the stack is empty or not. Is full. It determines whether the stack is full or not. Display. It prints all the elements available in the stack. Push operation. The step involved in the push operation is given below. Before inserting an element in a stack, we check whether the stack is full. If we try to insert the element in a stack and the stack is full, then the overflow condition occurs. When we initialize a stack, we set the value of top as -1 to check that the stack is empty. When the new element is pushed into a stack, first the value of the top gets incremented That is, top is equal to top plus 1 and the element will be placed at the new position of the top. The elements will be inserted until we reach the max size of the stack. Pop operation. The steps involved in the pop operation is given below. Before deleting the element from the stack, we check whether the stack is empty. If we try to delete the element from the empty stack, then the underflow condition occurs. If the stack is not empty, we first access the element which is pointed by the top. Once the pop operation is performed, the top is decremented by 1, that is, top is equal to top minus 1. Applications of the stack. Infix to postfix or prefix conversions, redo or undo features at many places like editors, Photoshop. Forward and backward features in web browsers, used in many algorithms like Tower of Hanoi and retraversals. In memory management, any modern computer uses a stack as a primary management of a running purpose. Each program that is running in a computer system has its own memory allocations. String reversal is also another application of a stack. Here, only one by one, each character gets inserted into the stack. So the first character of a string is on the bottom of the stack and the last element of the string is on the top of the stack. After performing the pop operations on the stack, we get a string in a reverse order. Stack also helps in implementing function call in computers. The last called function is always completed first. Stacks are also used to implement the undo or redo operations in text editor. Implementations of stack. A stack can be implemented using an array or a linked list. In an array-based implementation, the push operation is implemented by incrementing the index of the top element and storing the new element at the index. The pop operation is implemented by decrementing the index of the top element and returning the value stored at the index. In a linked list based implementations, the push operation is implemented by creating a new node with a new element and setting the next pointer of the current top node to the new node. The pop operation is implemented by setting the next operator of the current top node to the next node and returning the value of the current top node. Stacks are commonly used in computer science for a variety of applications, including the evolutions of expressions, function calls, and memory management. In the evolution of expressions, a stack can be used to store operands and operators as they are processed. In function calls, a stack can be used to keep track of an order in which functions are called and to return control to the control functions when a function returns. In memory management, a stack can be used to store the values of a program counter and the values of the registers in a computer program, allowing the program to return to the previous state when the function returns. In conclusion, a stack is a linear data structure that operates on the LIFO principle and can be implemented using an array or a linked list. The basic operations that can be performed on a stack include push, pop, and peek. And the stacks are commonly used in computer science for a variety of applications, including the evaluation of expressions, function calls, and memory management. There are two ways of implementing stacks using arrays and using linked list. Thank you for watching.